we are going to look at how to calculate the wavelength of light that is given off when an electron drops from a higher to a lower principal energy level. And this is going to involve a series of 5 different calculations, and they're given here in order. And the 5th one is actually a conversion from meters to nanometers. Okay, so let's look at an example problem. We are going to be calculating the wavelength of light when an electron goes from n equals 3 all the way down to n equals 1. It will release 1 photon of light, and we will determine its wavelength and its color if it's in the visible. So let's look at our equations we'll use. This is the first equation we use. This, the e to the n, this is the energy of the principal energy level that you're interested in. In other words, we will calculate the energy of the principal level 3 and the principal level 1, and we'll look at their difference. This RH here is Rydberg's constant. You don't have to memorize that, but it's just a number. Don't forget that negative sign. The N here is where you plug in the particular energy level that you're calculating. In this case, the 3 or the 1. So I calculated my energy of the 3rd energy level. Again, this is the constant, Rydberg's constant. And I plugged in a 3 here because this is principal energy level 3. And I get a number. Notice that it's negative. Now we need to do the same thing for the first principal energy level so we can see the difference in energy, which is going to tell us how much energy is in our photon. Anyway, so let's do the same thing, but for energy level 1. Okay, I did this for the first energy level now, and I have its energy. Again, these are negative numbers because the energy assigned to a principal energy level is negative. Okay, and so I have those two numbers. Now the difference in that will tell me how much energy is given off. We are not interested in the change in energy for the electron. We're interested in the energy that the photon contains. So they're the same number, opposite sign. And the way it works out, you're basically going to flip this. But let's just look at the next equation. So this is to get the energy of the photon that's released. It's not a final minus initial kind of thing. You'll do upper minus lower of these. And by upper, I mean the n equals 3. And the lower is n equals 1. So I'm just going to plug in those two numbers. So I did the n equals 3 energy and the first energy level energy. Of course, I have this minus minus here, so my answer will come out positive. And so that is my energy of the photon that is released. And again, it should be a positive number. The energy of a photon is always positive. And we have a relationship between the energy and frequency, so we will use that next. Okay. This is the equation that relates the energy of a photon to its frequency. We're going to use this energy we calculated there. This is Planck's constant. Again, you don't have to memorize that, but it is a 4-digit number. And then we're going to solve for frequency. So let's see how that looks. Again, I use this energy of the photon here. This is Planck's constant, and I'm going to divide to get my frequency. So I divided to get my frequency. Notice that the units come out per second. And again, this is another positive numbers. All of the numbers from here on out will be positive numbers. Will give us the wavelength. C is the constant, the speed of light, another constant. Wavelength is what we're looking for now, and frequency we'll just plug in from there. So again, this is the speed of light, a constant. This is our frequency from above. I'm going to take that and divide it by my frequency. My units, my per second, the second on the bottom will cancel out, and my wavelength will come out in meters. So now I have my wavelength of light that is given off in meters, but in lab we're going to need to convert that to nanometers. So the last thing is just a conversion. 1 nanometer is 10 to the minus 9th meters. So that's how I get there. And for my final answer, so for a transition from n equals 3 to the first energy level, I will get light given off, and it'll be 102.6 nanometers.